running a bit over time, but I'm sure you can manage. And even though the session was about food, we are delaying you from getting to food. As our speakers gather here. So, while you think about your questions, I'd like to use the chair's prerogative of launching a question of my own. And three of you raised the issue about community acceptance of some of the new technologies that we have. And in the agriculture and food sector, we have I suppose, the disastrous experience of genetically engineered crops, which have been almost universally adopted in some countries and almost universally denied and are stopped in other countries. And even after 30 years of safe use of that technology, it's still extremely problematic in many parts of the world, particularly Europe. Now, Amy, you particularly talked about some of the actions you've taken to work with the social scientists to address this. I wonder whether if you and the panel could sort of tease out a little bit more about how we in future can improve our interactions with the social scientists and make sure we don't face similar problems with some of these great technologies we heard about this morning.
Mm-hmm. It's an excellent point, and I think something we've thought a lot about the analogies to GMOs and sort of the public perceptions of that technology as well. I think part of the distrust about GMOs, for example, has come about with the domination of particular companies, for example, over these products. And so I think to combat this, I think that's where academic institutions and researchers in academia have an important role to play in communicating the launch of new technologies into the public sphere, particularly around novel foods. I think companies are clearly playing an important role in marketing as well and in communications, but I think if we can drive dialogue around these technologies, encouraging transparency around how the products are being developed and the impact that they might have, I think that's an important first step. I think with a deeper understanding of public perceptions and fears or challenges, that also helps us to better direct our communications and target, for example, in the case of cultured meat, a lot of consumers out there are very aware and recognize the impact of foods on the environment, and so if we can better understand the potential reductions in greenhouse gas emissions, for example, that we could achieve with cultured meat, that could be a way to kind of counter some of the negative perceptions and dialogue out there. But I think it's super critical for researchers and in academia to be able to contribute to that dialogue. So I'll turn it over to
anyone else care to risk a comment on that? Avi?
Yes, I may add that perception of people, okay, you will have always. If you saw in the corona, okay, a significant, or I don't know if significant, but it was a voice not to use the vaccination by messenger RNA, okay? So those people will stay always. What we have to do is to leave this side or the people that think differently as isolated, okay? And actually there is a GMO already, GFI, that is doing an international effort to have the cultivated meat as part of our future. Okay, but you never know.
I can't see too well from here. Oh, yes. Yep, go for it.
I don't think we could have had better demonstration what yesterday the panel on the HO biology meant to say. Thank you so much for this wonderful presentation. So I have two questions, if I may. One is rather specific and technical, which goes to Gabriela and to Jean-Francois. How far do you think we are from the stage where we will be able to double the light use efficiency of the photosynthesis at a scale which would be applicable to the challenge? That's for you, Gabriela. And to you, why is this possibility not explicitly included in all these scenarios, which I think are very comprehensive. A second question goes to all of you. We seem to have two trends here. One trend is to do what we can to improve efficiencies and management, and etc., including the one on the, but still stay with nature, still stay with plant, and still stay with animal. The other one is mind-boggling, really. Cultivated meat, getting 90% plus reduction of all possible negative things. So which of those two trends will win? And the one on the meat cultivation reminds me other trends I know very well, like the hydrogen, for example, like the desalinization of the water. The only issue there was the cost. And in both cases, like the desal, at the moment the cost became lower for the general use, technology won at large scale. It will happen to hydrogen too. So what is the threshold in the cultivated meat? Is it a price only, except of all the consumer preferences? So which trend will win, and when the breakpoint will come for the large-scale use of those technologies?
So
I guess
Gabriela.
I'll start in response to the portion of that. So what simulation suggests is that optimization of the specific aspect of photosynthesis that I talked about will give you a maximum of 30% increase in biomass. So the doubling, the 100% increase that you talked about, certainly can't come from one individual piece of that. And I think this just serves as an example of the need for fundamental studies of many different aspects. So I would say in many ways we're pretty close to the knowledge, but how that implementation will be achieved is still a really open question. If it's going to be achieved by looking at a variety of different strains, you know, sort of some of the incremental approaches that Jean-Francois talked about, through transgenic or GMO approaches, which have all the problems that we were just kind of brought up, I think that that's still an open question. So, you know, I think in some ways there's a lot of fundamental knowledge that could already be pushed forward, but it's really about that integration with policy and social sciences that is in many ways limiting the next step for increasing the global primary production.
Thank you. Well, thank you, Pavel, for your question, which is highly relevant, obviously. So as Gabriela explained, we have a perspective here to increase primary productivity in crops through such actions. I would like to cite work from colleague Stephen Long from, I think, Ohio State in the US. And Stephen has been really leading efforts with GM modification of crops like soybean. And he achieved actually increases in crop yields in the field. And this was why, by working, I think it's quite complementary to the work from Gabriela, on the adaptation of plants to the rise in atmospheric CO2. So we do understand that plants were evolved actually in lower concentration in CO2 than today. So there is possibly a perspective of re-engineering photosynthesis to adapt to higher CO2 levels. And that has been achieved in the field with around 20% increase in grain yield. Same for other works with actually adaptation to oscillating light levels, which were proven to increase the grain yield. So this is really relevant, and I'm with you when you say I should do some further efforts to include such innovation pathways in the sort of modeling we are developing. Yes, this is a very nice perspective, and we should do this. However, if I take a step back and come back to what you said, Peter, about these problems with GM we faced in Europe at least, and I think it's also true with other countries, we could also relate it to your work, which is quite fascinating, because in some sense what the big players in the seed and herbicide markets did is to create a miracle solution, you know, a plant that would survive a herbicide that they were selling. So for the value of those companies, it has been a huge, obviously, benefit. But for the consumer, given exactly what you explained with the evolutionary games, which means that you're not always going to win with the weeds, because they will in fact adapt to your herbicide, this means that we have created huge problems. There are many countries where we are now using herbicides with no more efficiency because they are herbicide-tolerant weeds that are just surviving everything. So you know, it's an interesting example of an innovation which was of huge benefit for companies, but possibly not solving the problems to the scale needed, you know. So I'm not a specialist at all about cultured meat, but I must say I'm a bit skeptical because when we saw your figure about the 92% decrease in greenhouse gas emissions, I would like to challenge this because it has been a number of papers showing that if you take a life cycle approach, you do use energy, you do use some nutrients, some chemicals, and so on. So in a life cycle approach, you're not going to reduce as much the greenhouse gas emissions. However, it could be you could reduce it, but not to this large extent. So let's always try to have a balanced view about our innovation and the long-term impacts of the innovation. Otherwise, there will be a backslash on innovation. Please realize that a number of people everywhere in the world are really skeptical about the potential of technologies because of those past backslashes. So we need to really work with everybody to create sound innovation.
Avi, you wanted to comment on this as well?
I'll comment on, first of all, I agree with you 100%, okay? And you know, the people say 15% reduction if we get rid of all the ruminant animals, but I doubt if this will be the case because I believe that only 10% or 20% of the people will switch from real meat to the cultivated meat. Okay, so this is one issue. Okay, but still, from business side, you have to say otherwise. Yeah. Okay. The second issue of the cost of producing the cultivated meat, the main cost are the growth factors. There are 4 growth factors that are used, and they, I think it's 90% of the cost is just the growth factors. So what we try to do is to find alternative for the growth factors or a way how to make them much cheaper than what we do today. Because today we take growth factors that are used for human therapy and use it. Because of that, it is highly expensive. But if you can find a way how to make it in a cheaper way, then you solve this issue.
Melanie, I think you've got a question.
Thank you. So I'm going to raise the level at which we're looking at this. So obviously, this is a very complex system with many different factors. And if we really want to achieve sustainable human nutrition and a healthy planet, I'd be interested to hear from all of the speakers this morning about what one shift you think we could do now that would make the biggest difference. And I know that's a challenge because it's a complex system and it's putting you on the spot a little bit, but I'd just be really interested in those perspectives. Thank you.
Right. So we'll start with you, Amy, at that end of the table, and your answer to that question and work our way through.
One shift right now, I mean, I think the regenerative agriculture approaches that we heard about have a lot of potential. They're already being implemented on smaller scales, and that I think has lots of environmental benefits and also human health benefits. I mean, clearly into the future, I think clearly novel foods, I think, can play a role as well, but we need a diversity in approaches, I think. But since you asked right now, that would be my answer.
Thanks. Gabriela.
I'm going to say moving towards more widespread testing and investigation of transgenic or GMO lines for increased biomass.
Okay, that was an interesting one. Peter.
Well, to return to that earlier discussion about genetic engineering, I think the messaging is probably a little skew on that. I think there are pluses and minuses, and I think the public tend to respond more to negative news. And genetic engineering isn't one thing. There are uses and misuses of the technology, and it was mentioned that people are slow to pick up technology, but they're not really. It depends on how attractive that is. And so I think if the messaging around the positive aspects of genetic engineering is tweaked, I think that will make an instant difference to how that technology is applied and how soon we can benefit from it.
Okay, Jean-Francois, what would you go for? Everything.
Yeah, my plea is really about a systems approach, connecting different things, so it's a bit difficult to answer. But, I'd just like to say a few things. One is, if you just look at, in a classical sense, food security, which is like a number of people that go hungry, then it's really a food access problem. It's not a matter of increasing production. We have enough production. And so it's far more about everything about food insecurity, conflicts, wars, climate change impacts, and so on. If you think about huge impacts on health that we have with malnutrition, chronic diseases, please rebalance your diets. We could do it. Public policies are amazingly weak on this. There should be strong messages about rebalancing our diets. If it's about then how can we, in the long run, have sustainable food systems, please consider soils. Soils are really depleted in soil carbons. They are unhealthy. Even in Europe, the Joint Research Center from the European Commission shows that 60 to 70% of our soils are unhealthy. Well, unhealthy is a bit vague, but there are 8 criteria. I don't have time to detail. And lack of soil carbon is one of them. So, answering different problems, prioritize things in different ways. That's possibly my message. I agree with regenerative agriculture, if you like to call it in this way. Protecting soils and using a bit less inputs would be beneficial.
Yeah. I actually remember there was an old analysis from the FAO estimated that less than 20% of the world's agricultural land soils are in a healthy state. Yeah. 80% are severely degraded. Yeah. So next.
As we have been hearing, there are so many fronts that people can work on for this, and people are working on, and definitely improving crops from using different techniques, from genetic techniques, or combating pests and pathogens, also using those techniques, but putting them together with what is well known, like something which go out of fashion, like biocontrol methods. So there are different ways in what one can go forth with that, but also something that I saw a picture of, but we didn't discuss much about, is also controlling food waste, because exactly as you mentioned, like there is a lot of production, but a lot of it also is going waste. So something in that direction. But to cover all of that and give one answer would be actually to somehow be able to fight misinformation and then lack of information. So controlling for both of that. So controlling the misinformation which is there and providing more information. I think that would go a long way in promoting all these different techniques.
Difficult one. And Avi?
They say everything, so I have to be something different.
Something new now.
Yeah, so I would say that better fertilizers that are more friendly and more effective. And I know that there is a project in the United States that the VAX program to exactly deal with this issue. And I think that this is a major issue.
Yeah, there's certainly a lot, I think, happening in changing the formulation of fertilizers so they are more effective.
So are there any other questions out there? Yep, there's a hand waving here.
There's a light over there too. I can't see him.
Yes. Okay. Thank you. My question is to Gabriela. In the 2 mechanisms that for heat regulation that you have nicely demonstrated, are these 2 mechanisms, maybe my description is a bit naive, are they complementary, or are they maybe a form of redundancy for the trees? Thank you.
Yeah, thanks for your question. So they're complementary. Photosynthesis, like all biological systems, is mathematically speaking a stiff problem, right? So there's dynamics on a lot of different time scales. So those 2 different mechanisms give responses on 2 different time scales, essentially, a faster and a slower one.
Okay, any others out there? Where are you pointing?
the light's going to come on and then I can't see.
I wish we, yes, thank you. I wish we had a chance to get a stronger input from humanities, like psychology or sociology. You know, I'm a happy father of kids I try to convince to eat broccolis and endives and tofu. And now we're talking about having a substantial fraction of the humankind changing its taste and eating some kind of goo that it never had any tradition for. So I think we really need to figure out how we can change people's taste in a reasonable time. I'm not talking about a generation time scale. It's much shorter than this.
Yeah, a good question, but probably one that's going to be very hard to answer. I don't know any of the panel would like to. How do we actually tackle this?
I can jump in. I'll take a stab. Yep. I think it's an excellent question. I think that really drives a lot of our work in generating novel foods that simulate and are mimicking foods that we already know and love, like the milks and meats. Achieving behavioral changes and changing people's diets is something, you know, there's lots of campaigns you can point to around the world, but those kinds of behavioral changes are really hard to achieve, especially around food, where it's so deeply rooted in our cultures and evolution, even to eat high-protein foods. So I think that's where this first generation of novel foods is heading, right? To just mimic foods that we already know, so that it's not like goop. It's actually something that we recognize as a piece of meat. Into the future, I think there's really exciting potential to start to think about more precision foods, or tailoring foods to people's specific tastes or nutritional needs. That's sort of another level of that goes beyond probably the scope of our discussion today. But I'll turn it over to any other panel members.
The food industry doesn't have a great reputation, and pumping up sugar levels, fat levels, and salt levels have been the key new additives.
If you can now make meat that has, for example, a more healthful profile of fatty acids or higher protein content, or doesn't have heme, which is one of the putative causes of associations with colon cancer, I think we can imagine engineering more healthful foods that aren't just engineered for maximum flavor.
Jean-Francois.
Yes, thank you. No, there is certainly a lot to do in terms of innovation. We have in France a challenge about innovation on fermented food. And fermented food is actually anchored in a number of traditional food cultures, with the tofu, for instance, but please consider the cheeses in France. We are quite proud of our cheese, and so on. And certainly fermented food has a lot of potential, also with a rather sound environmental profile in many cases, to make a difference in terms of innovation in the food systems. We have also a fully renewed understanding of the health impacts of food through the interrelation with the human gut microbiota. And that's a fantastic, I think, perspective in integrated biology. A number of the chronic diseases appear to be correlated with shifts in the human gut microbiota. And I think if we consider also some of the past efforts to produce highly processed food, we now realize that some of the chemical additives in those food are impacting negatively the human gut microbiota, therefore creating some imbalances that could lead to chronic diseases. So this is also another pathway to link understanding in terms of human biology with the microbiology and also with the food innovation.
Thanks. Chaitanya.
Right. I mean, I'm not very, very qualified to answer the question about the behavioral changes, but I think that's just the result of me hanging around with way too many behavioral psychologists. But what I learned from them was also like the stories about the culture of our food that we tell ourselves are really strong because we tell ourselves, a lot of them. If you look at the history of food from these different cultures, it has changed so fast. I mean, associating tea with UK, chili food with India, chocolates in Switzerland, I mean, where they came from after the Industrial Revolution, I think that's something which changed very fast. And I think that it is possible to make these changes. Also, it's again going back to like how we incorporate these new concepts into the culture and how we put them in. I think that would make a difference. But it is possible that behavioral change does happen fast enough. You don't have to wait generations then.
Okay, that was a difficult question, but interesting to hear the different perspectives on it. I'm going to use my prerogative as well. I was struck in both Gabriela and Peter's talks about the fact that there was lots of diversity still in the living system. So Gabriela, you showed us the differences between Arabidopsis, moss, and your alga. Peter, you talked about plants at different rainfall levels having different responses to water use efficiency. I'm wondering whether you think, in amidst all of this very high-tech approach, there's still diversity out there in the natural systems that we haven't explored that might actually help us tackle some of these problems.
Absolutely. You know, one of the strengths and weaknesses of biology is that we end up with a few model systems that we develop really robust tools to look at. You know, E. coli or Arabidopsis, which is the E. coli of plant genetics. And so that's a strength, the ability to kind of handle those proteins, manipulate those proteins in cells, but it's also a weakness because, you know, the ecosystem is incredibly diverse. And so evolution has really potentially identified unique solutions that we could certainly explore. And I think, you know, some of the people here today have explored them, for example, in cyanobacteria.
Well, I would say yes, the biodiversity, again, we need to probably think about how to use that biodiversity a little differently. Thinking about my own work, some of the problems we've had, even that example I talked about in parameterizing those models, it was kind of seen as an enormous task because at some level all plants are different, all species are different, but if we can find common threads through that biodiversity that they all share, I think that's what we need to understand a little better as to what are the commonalities amongst the biodiversity that we can use to simplify our models and our systems to make them more powerful and more general while accommodating that biodiversity. I mean, the photosynthetic process, all leaves have photosynthesis. At some level, there are these common threads that run through that biodiversity, but we need to discover them and utilize them a little better than what we're doing.
Okay, thank you. I think that's a really nice way actually to wrap up, to think about the commonality of process, the differences there are to find, and the way we bring that together with these novel approaches. So I'd like to ask everybody to join us in thanking our 6 speakers for a really interesting, engaging morning.